HVAC, the condensed version, presented to us by Dometic Industries. Ben Haynes from Dometic is the one that's here to present to us. Ben is the Director of OEM Sales for Dometic. He began his career with Dometic back in 1987, same year that the International Yacht Brokers Association, formerly known as Florida Yacht Brokers Association, got their start. He started work in the production of chilled water air conditioning systems. After working in production for 8 years, he moved into customer service, where he worked until 1998, and then made the move to sales. Ben would become OEM sales manager for accounts in the Midwest, Northeast, Southeast, Northwest, Canada, and Asia Pacific. That's a lot of territory. In 2015, he became director of OEM sales for the Americas and Canada, and his main focus is on commercial custom builds and super yachts. Ben enjoys working closely with customers and associates in projects-based business through the Americas and Canada. He's working directly with the boat builders, shipyards, and design firms to specify, consult, design, and commission all of the equipment that Dometic offers. Currently focusing on air conditioning, refrigeration, sanitation, ship-wide ventilation, RO desalination, RO freshwater systems. Not a busy guy. Ben currently resides in Jacksonville with his wife Denise of 27 years and their 2 beautiful daughters, Caitlin and Emily. Ben Haynes from Dometic is going to give us our first section.
Thank you, Paul. Well, I want to first start off by thanking the International Yacht Brokers Association for having us here. Dometic, it's our first time here, and we're glad to be here and be able to present this this first round. Condensed version, it's very difficult for me to do anything in a condensed version, so I'm gonna try my best to keep it on task and not drift away. So this is an engineering conference, I'm gonna give more of a, I am in sales, but we are more of a technical sales, so more of a sales approach to air conditioning to hopefully help you guys in the future, one, understand it, know some of the ins and outs of it, to help you guys sell and explain to your customers HVAC. I'm going to first start off with the definition of air conditioning. As I Googled definition of air conditioning, I had to change it a little bit because marine is just a little bit different than the standard air conditioning. Air conditioning is the process of removing heat from a confined space, thus cooling the air and removing humidity. That's a big thing. You think of air conditioning as cooling a space, but really what we're doing is removing the heat out of that space and also taking the moisture out of the air, making the space comfortable, cool, comfortable, and dry, which is a big thing. And removing humidity is a bigger task than it is to actually bring the air down to a comfortable temperature. Air conditioning can be used in boats of all sizes. We manufacture air conditioner and deal with a lot of different boat builders. We do air conditioning from boats from 20 feet on up, 200 plus. So there is an air conditioning for every size boat. The process is used to achieve more comfortable interior environment, typical for boat owners and crew. So the big task is, and what we're up first is to make everyone comfortable on the boat and having a comfortable environment. However, what we don't usually realize is more and more electronics and exotic woods and arts are put on these boats, and it's crucial that the air conditioning system runs and maintains on a constant basis, especially on big super yachts. If they go without air conditioning, one, no one's going to be on the boat, no one's going to want to use the boat, and two, there are things on the boat that are going to suffer because of it. So air conditioning is a very, very important piece of any yacht. Now, this is the technical version of air conditioning I'm going to run through real quick so you guys can kind of get a view. In air conditioning, this is a refrigeration circuit. We have what we call a heat pump system, which a typical home here in Florida and North Florida use heat pump systems. So what we basically do is we use the air conditioning condensing unit and we actually reverse the flow. One direction we're getting cool, the other direction we're actually getting heat. Over here on the left-hand side, this is an air conditioning side of the refrigeration system. And the heart of every air conditioning system is the compressor. And what the compressor does is it takes gas in the low side and compresses it and sends it out the high side. So as we come out of the compressor, we start with a high pressure gas that actually goes into what we call the condenser, which is the red up here on the left. In the marine environment, a condenser is actually a water-cooled condenser. In your home, if you go outside, there's the condensing unit sitting outside. You put your hands over the top of it. There's hot air coming out. That's the heat that we're actually removing out of the space and expelling it into the air. But in the marine industry, especially the pleasure boat industry, we use the raw water, the seawater, to do that. For one, you don't want to have these big condensing units sitting out on top of your boat. And two, it's in a hidden space in an engine room or machinery space where it's out of view of everything. So what we do is we actually have a coil, what we call a condenser coil, which has an inner tube that seawater flows through, and then it has an outer tube which the refrigerant flows to. So as the gas comes out of the compressor, goes into the condenser as a hot gas, as the water runs one direction, the refrigerant runs another direction, we're actually absorbing the heat out of that refrigerant. So once we absorb that heat, the water runs through the coil and then gets put overboard, and that's how we get the air or the heat out of the refrigerant. That's a more efficient way of doing things because water temperature is usually more constant than air temperature. But in marinas all over the world, depending on where you're at, that temperature can range from 50 degrees all the way up to 125 degrees. So you got to build systems that are actually have the ability to maintain in any environment. So once the refrigerant goes through the condenser as a hot gas, as it goes through, it actually condenses, it actually becomes a liquid. So as it comes out of that condenser after we've removed the heat, it comes down through here and it comes to what we call a metering device. On a big system, it'd be called an expansion valve. On a small system, it's called a capillary tube. So basically what we're doing now is we're taking this hot liquid, we're putting it through a pipe, and then we're squeezing it through a tiny little hole, and as it comes out the other end, it expands, and that expansion actually causes the cooling of the refrigerant. So once you come out the other end, you're coming through here, kind of like a saturated liquid, you come up to the fan coil unit, which is the unit inside the boat, or in your house, however you want to relate to it, that has the coil and the fan. So as that refrigerant goes through that coil and the ambient air that's in the space recirculates through there, we actually remove the heat out of that air as it rolls through that coil. And then what we also do, these coils all have aluminum fins on it, and you'll see there's always condensate pans under all these fan coil units. So as the moisture in the air collects on that fins, it rolls down, goes into the condensate pan and drains out the boat. So we're removing the heat, in turn cooling the air, and then we're also removing the moisture out of that air. So once that gas goes through that coil and we actually heat it back up again because we absorb the heat out of the air, turns back into a gas, goes back through the compressor, and repeats that over and over again until the room gets satisfied and temperature and humidity is reached in that space. Now when you want to go into heat, basically we switch directions of the refrigerant. As you come out of the compressor, we actually, as a hot gas, we actually start with the fan coil unit inside the space. So we have the hot gas go through the coil, the cold air from the room gets circulated through that coil, in turn we heat everything. And as we do that, we actually cool down the gas, turns into a liquid, goes through the metering device, expands, goes into the condenser, which is outside, runs through the condenser, and at this point now what we're doing to heat, we're actually absorbing the heat out of the water that's circulating through that condenser to warm the refrigerant back up to heat the room. So that's basically how a heat pump system works. Now some of the things that you got to watch out for in these type of systems, when you're in the heating mode, there is some limitations because if the water gets too cold, below 40 degrees Fahrenheit, there is no heat to remove out of the water. So there are limitations to a heat pump system in the marine environment. So what they'll do is they'll usually use electric heat, either resistive in the air handling unit, or an immersion type heater that's actually, if you have a larger chilled water system, that will actually heat the water in the system. So when you get in that cold water situation, we go from the heat pump to a electric heating type system. And then also on the seawater side, that does, seawater ranges in different temperatures, 85, or really anything 60 to probably 90 degrees is the optimum level for peak performance out of air conditioning. Anything you get up higher than that, you start losing a little bit of efficiency. So seawater is always important to keep good flow and keep at a moderate temperature. There are three different types of air conditioner systems in the marine industry. There is the direct expansion self-contained, which is on boats up to about 40 feet, or 12 meters. It's a small, self-contained, completely contained system, very easy to install, and again, built for the smaller boat industry. Once we get to that 12 to 21 meters, 40 to 70 feet, we actually get into what we call a split system. So we take that same self-contained system and we take the compressor and the evaporator or fan coil unit, split it up, put the fan coil inside the boat, put the compressor in the engine room or machinery space, and connect the two with refrigerant lines between the two. Once you get above that 21 meter range, we get into a chilled water system. Now this is, when we get into boats this big, we're looking at, if we have multiple fan coils in every space, you're looking at 20 to 40 different fan coils all around the boat. You get into a chilled water system. So we, instead of using, as we saw in the, before the refrigerant cycle, instead of using the refrigerant to actually cool the air, we're actually using refrigerant to cool water, which then cools or heats the air. A direct expansion self-contained system, it has cooling, and it cools and heats. It has a heat pump system, the standard units. Self-contained systems, no refrigerant charging. They're self-contained. Anybody can put them on. You put them in a boat. You actually install a duct, electricity, and raw water to them, and they're ready to go. Very compact in design. Very simple installation. Optional electric heaters. We can get induct electric heaters for cold water situation on those units. And then a lot of the self-contained units that you see out there, they're available in AC voltage and DC voltage. For smaller boats with small cabins that don't have generators, there's little small 3,500 BTU units that are out there that will actually, they're DC powered and will actually run off of batteries. So with these smaller systems, you do have some flexibility in voltage. They're low amperage, it's a low cost system, low cost installation, and very, very lightweight. This is a typical installation of a self-contained system. You have two units which are mounted inside the boat, one in the salon area, one in the V-berth area. There's usually a system for each space being cooled. There would be a control unit for each unit, so you can control temperatures separately in each of those spaces. And then what you will notice is a back here in the back, there's a seawater pump mounted right there that pumps the raw water to each of those condenser coils that we talked about to remove the heat. So that's a basic setup. You got your raw water pump into each of the units, and then you've got your inlet, you got your supply air ducts, and then you have your control for each space. Direct expansion split systems benefits, again, with the split system type unit, you got cooling and reverse cycle heating, quiet operation with the compressor and the machinery space. So when we get into bigger boats, that 40-foot on up range, there's a higher perception for noise and stuff like that. So what you do is you actually take the compressor, which is the biggest noise maker, put it in the engine room or the machinery space, and move it out of the interior space to quiet things down. So, and then in the interior space, you only have a fan coil unit with a blower on it. So a lot quieter operation, one compressor unit for each space. So you got, for every compressor, there's a thermostat. Fan coil units in each space being cooled. You do have the option for electric heat. And then there's various fan coil configurations, because as we go on in this industry, I notice the interior space becomes a premium and the space to hide everything goes away. So we are always challenged as a manufacturer to come up with different configurations to fit in all the little hiding spaces that are left for us to put air conditioning. So they are in, we'll have ceiling mount, stuff behind lockers, under benches, in walls, anything we can do to find and create items to fit in the spaces that are left for us. There is a copper line, two copper lines that run between the condensing unit and the evaporator that are refrigerant charged. It does take a licensed technician to install one of these systems, because you do have to evacuate and charge the system. It's moderate costs, moderate installation costs, and very lightweight. And then this is a typical installation where you'll see two compressor units in the back here. You got your seawater pump which is actually pumping water to the condenser coils, and then you'll see the refrigerant lines go up to each fan coil, connecting to each fan coil to send refrigerant to and from those fan coils. Two things with this installation that are key on a bigger boat. As I said before, you've got the compressor, which is the noisemaker, in the engine room out of the accommodation space, so it's quiet. But another thing is when you get into bigger boats, and we've had some people do this, and you start putting package units, self-contains for the smaller boats and bigger boats, and you start getting 5, 6, 7 of those things all around the boat, you have to pump seawater to each one of those units. So the problem there is, especially in South Florida, growth in seawater line is huge, and maintenance starts to become a nightmare when you get too big of a boat and have a bunch of self-contained units on it. So it's always good to watch out for that and have the appropriate system for the appropriate boat. Because here now, both units are sitting in the aft section in the engine room. All your seawater is contained to that small little space right there, so maintenance and stuff like that becomes a lot easier. So it's a quieter installation and easier to maintain. Now, to tempered water or chilled water systems, really the basic difference with chilled water is, as we explained the refrigeration loop there before, is that instead of having air to gas to refrigerant connection, we actually have a chilled water loop through an entire boat. So what we do is basically have 3, 4 compressors in the engine room depending on the size of the boat, and its sole job is to cool a chilled water loop to 45 degrees Fahrenheit, or in the heating mode 115 degrees Fahrenheit. And then that water is sent to each of the fan coils throughout the boat, and depending on if you're heating or cooling, there's a water valve on there that opens and closes pertaining on what you're trying to do inside that space, whether you're heating or cooling. Tempered water system benefits: multi-stage compressor system with complete redundancy. So as we have this rack of compressors, which basic job is to cool this chiller loop, as the boat gets cooled down and everything, you got air handlers starting to turn on and off, that 4 compressors might only need 1 or 2 to keep the system running. So once you maintain that temperature, you start dropping off load. And the good thing about that is, for one, if you're trying to load manage in a situation where you don't have a lot of power, you can shut off 2 compressors. And another thing is, if God forbid you had a failure, you still have the redundancy of other compressors to keep cooling that loop. And if it got to a point to where you had multiple failures, you could start load managing in the boat and picking and choosing what areas you want to shut off. When you have a direct expansion system, as we showed the earlier ones, those are direct cooling for each space. So if you lose that compressor, you lose cooling to that space. So chilled water gives you that flexibility. Another thing with chilled water, it's usually a custom type system because it's for bigger boats. So it can be made in a lot of different configurations. There's multiple types of compressors that are used, screw compressors, hermetic compressors. There's multiple types of condensing units depending on the size. There's coaxial type condensing units, and then there's shell and tube. They have reverse cycle and immersion heat options in there. Load management, as I said before, you can turn compressors on and off to manage load. It's a lower amperage when the boat's pulled down. You got multiple zone control, so every space has its own thermostat. Various air handler configurations, electric heat options on each of the air handlers. So if you have the system in cool and you're up in the pilot house and you need air conditioning, but the people down below are just getting up and it's early and it's cold, you got electric heat on there, you can actually heat and cool with the same system. Has humidity control, has a lot better humidity control. As we are using electric heat in air handlers, we can actually use that electric heat to pull down humidity further than, when actually control it a lot better. And then you have fresh air makeup options. We're able to bring fresh air, treated fresh air in to have several air changes, keep the air dry, keep the air refreshed, and just gives you more options. There's a typical layout for a chilled water system. You have your chiller system in the engine room area. You have a circulation pump that pumps the water recirculates the water through the boat to each of the air handlers. And then you have a seawater pump that actually pumps the water to each of the raw water coils on the chiller system. Then this is just kind of a larger version of a larger boat where you've got air handlers, you got chill water, the red and blue is chill water lines throughout the entire boat. You have several levels here. You got air handlers in every space, you got fresh air makeup, just kind of a layout of a larger system. And then this is a plumbing schematic that we do when we do projects, just to see the integration of this system through the entire boat. So you have plumbing, you have air handlers, you have chiller systems. It's a fully integrated system throughout an entire vessel. So it is a big part of the boat manufacturing process. Fresh air makeup systems, as I talked about before, in the chill water system, it gives you the option to bring in treated fresh air. So on a boat, what you want to do is you always want to keep a slightly positive pressure inside the boat so that you're not bringing in smells from outside. And then you're also wanting to change the air inside the boat. So on average, we usually see 3 air changes per hour. So what we do is we bring in a certain amount of CFM to manage that. And then the exhaust coming out, we just make that a little slightly less so that we always continue with a positive pressure inside the boat. If you're in salon areas or bar areas where you might have possibly smoking and stuff like that, the air changes might jump up to 6 air changes per hour. So as you get into bigger boats, fresh air makeup systems are on anything 100 feet plus. Normally always has a fresh air makeup system on it. UV light air purification. So as we talked about air conditioning, we dry the air, we cool the air, we dry the air, we make it comfortable, it's a healthy environment. Well, another thing that's good to add as an option is UV light. And we use this in a lot of applications because it's not harmful to your health. It gets rid of bacteria, fungi, keeps mold out of ducting, just keeps a good clean system, and it's easy to integrate. You can integrate it into the air handler unit, you can integrate it into the ducting, there's portable units for smaller boats. So it's an easy way to have a good air purification system on your boat. So UV light air purification, so this is kind of a setup of how it works. You have a UV light and you have what they call a nano mesh filter, and these two work together to remove contaminants out of the air. So it's a simple process. The only maintenance on it is every year you got to change out that UV light because it loses its effectiveness, and it's a very simple way of keeping the air, again, purified, keeping mold and stuff like that out of your ducts. And then this is the different ways that you're able to utilize this. As you see here, this is an air handling unit that you would have in your space, and this particular piece at the bottom here is actually the UV light installed inside of an air handler. This is the duct version where you actually have it inside of the duct. It's round to fit within the ducting, not take up any additional space. And then we have portable versions for smaller boats that could be used. And if this is something you want to try out, what we normally do is we hand out these portable versions to everyone, and if you got a room or anywhere in a boat or in the house and you put this in there, walk away from it for a couple days and come back, like if you have a pet or anything like that, you'd be surprised what the difference is when you come back to that space.
In terms of what?
Sorry?
In terms of what that you would feel a difference?
You would like smell. Let's say you had a room that you kept a pet in, or you had a room that someone smoked in. You put this in here, close it up for a couple days, come back, and that UV will actually clean that space up. And usually, like I said, that's usually the hook to get someone is give them the portable unit, let them try it, and then they realize how it works, and they usually end up installing on the boat. One last to go over is, with as important as the air conditioning systems on the boat, and like I said, with electronics and everything, a lot of these bigger boats are running 24/7. Maintenance is key. You got to keep these systems maintained. On a daily basis, seawater strainers, that brings that raw water to remove heat to the condensing units. Very important to keep that clean. On a monthly basis, all these air handling units that are in the boats all have air filters that have to be cleaned to keep good airflow across them. On a more quarterly basis, if you have a chilled water system, like I said, it's a closed loop system that pumps water through the boat. The water pressure in that system is key to keeping that at a 15 on the PSI on the suction side and about 35 on the high side. You got to maintain that to keep proper flow. Always check your condensate drains on a quarterly basis, as they're always removing condensation, and you don't want those things to get plugged up. For one, it can create smells, and two, if it overflows, it can create a mess. Another thing, like the seawater circuit, which I said before, you know, especially here in South Florida, growth is rampant. Over the last probably 5 or 6 years, I think it's even gotten worse. In fact, that some of the materials that were used before, we're having trouble using them now, and things are shifting to titanium and stuff like that to be able to handle the cleaning process and stuff that happens with growth. So always key to keep that seawater circuit clear for the performance of the equipment and also for the longevity, because if you block off the seawater flow, compressors run hotter and the life expectancy shortens on those systems. Chilled water on a yearly basis, again, we kind of went over everything. Refrigerant, check to make sure your refrigerant's where it needs to be. I mean, usually you don't have to do this. If your refrigerant is low for some reason, there's a leak. So refrigerant's a sealed system, so you never have to check it. If you're going to put the boat down away for the winter, you've got to winterize. Any of the water circuits, of course, have to be filled with glycol. And for chiller loops, chilled water system loops, and there was someone we talked to this morning on this, that closed loop system that we cool, it is very important that glycol, a 20% mixture of glycol, is put in that system to protect it. Because if that system gets too low, starts getting cold, you could actually freeze water in there and have a big problem with your chilled water system. So glycol is very important inside the chilled water loop. And on a yearly basis, the mechanical portion, the pumps, seawater pumps, chill water pumps, all have to be checked for proper operation and that everything in water's flowing properly, which is a big part of these systems. And that's it. I ran through it.
Perfect, Ben. Thank you very, very much. We have time for a few questions. I think we had one question right up here. There's a microphone coming to you right now. Be patient.
I have a pretty good voice. You mentioned mold and the UV light. If we have a portable unit in a cabin which perhaps has had mold in it in the past, not saying that I've ever experienced that, but in case it has, are you comfortable that just putting one of these portable units in there briefly will eliminate any mold that has occurred in under the surfaces of all of our upholstery and all of that?
No, it won't eliminate mold. It will prevent mold. So if you have mold in a boat, you have to get it cleaned and removed, and then you put these systems in, and it will prevent it from happening again.
Oh, very good. Thank you.
You're welcome.
Do we have any other questions with our HVAC? Right next to you, Amy.
Are these R22 or 410A?
410A.
Can an R22 convert to 410A?
No, it cannot.
So if you have an R22 system on a boat, you have to pull it and put it in 410A in?
You do. Now, you do. I mean, R22 it's still legal to use out in the aftermarket. It's illegal for a manufacturer to build equipment with R22 in it. So it's still readily available. If you have R22 systems, you can get them repaired. They're great systems. They work fine. But we just cannot manufacture new units with R22. So what we'll do is, for older systems, we actually manufacture equipment with 417 refrigerant in it, which is legal. Once you get that out in the field, you can remove that and put R22 in that. So there are systems still built for older boats, so you don't have to do the switch over, because if you had to switch to 410A, you'd have to remove everything and replace it all. So there's still systems out there that you can use to fix older equipment with R22.
Awesome. We have one up front here.
So what is your take on chlorinization for eliminating the need to descale frequently?
Chlorinization, I mean, I don't have a problem with it, especially with the materials that we're using now. For descaling, fresh water. If you can flush your seawater circuit with fresh water once a month, you would prevent growth inside of a line. There's so many builders, the sport fish guys have really tuned on this, and they actually build systems in their boats so that they can close a few valves and just recirculate fresh water through their raw water system, and the fresh water kills any of the growth that saltwater comes from salt water. So that's a good way to do it. Red lime is another one. Descaling solutions. You just want to stay away from heavy acids and stuff like that, because you will, after time, and doing it repeatedly on copper nickel type stuff, you will wear out those coils.
Thanks. So. Hang on one second, Charles. There's one back here.
Just going back to the mold issue. I understand what you're saying. If you put a UV system in a room that's full of mold already, you might make it smell a little better, but you're not going to kill anything. Is there any scientific data on the effectiveness, or is it just looking in a duct in the condensate coils and not seeing mold with the UV?
Yeah, there is documentation. We have a guy, one of our engineers that did, before we started this, put together a bunch of paperwork so that people who had questions and wanted data to go through, there is scientific data that shows it. Yeah, test reports. So we've actually had tests done so we can prove that it works. Like I said, usually mold, the reason why mold is caused is usually humidity. Usually you're getting warm air. Usually there's a problem that causes it to begin with. UV light will help keep that away, but if it's a constant problem, I mean, I've been on boats where I pulled headliners down and you just wanted to run because of what was up there. But that's a problem. You're getting warm air in from outside, warm humid air that's causing that problem. So if you have a real bad mold problem, you want to clean it up, and then you want to find out why you're having that. So, but to answer your question, yes, there is data to back up the UV lights if you need that for someone.
Excellent. Charles?
A typical, some boats, you might have 3 air conditioning systems and 1 raw water pump that cools all 3. Is there a particular criteria or threshold where you'd want to have one-to-one relationship between the raw water pump and the units?
You can size a pump, everything's based on gallons per minute and foot of head, so you can size a pump for anything, but you probably want to stick, if you're talking small self-contained type units, you probably want to stick to no more than 4 units on 1 pump. Because the problem is going to be is to try to actually truly get the proper flow to each unit, but how you manage that sometimes become difficult, and you always worry about one unit getting more water than the other and causing a problem. So I wouldn't go any more than 4 units on 1 pump.
Great. Any other quick questions? One in the back. That'll be our last one.
2-part question. The UV air purifiers, will that pull the diesel smell out of a boat or cabin?
Yes, it will.
And regarding strainers and raw water systems, is it possible or available to have a system that actually cleans itself?
There are systems out there where they use different metals to kill growth before it comes in. There are attachments that can go on top of strainers where you can actually put cleaners in there.